Assalamu alaikum warahmatullahi wabarakatuh. You are welcome to math class today. In this class, we are going to be talking about integration. In our last discussion, we concluded our discussion on differential calculus. So the opposite of that discussion is integration, integral calculus. So what do we stand to gain at the end of this class? That is our lesson objectives for today's lesson. One, we are going to be able to define integration. We are going to be able to state the forms of integration. We have two forms of integration. We have the definite and indefinite forms of integration. And finally, we are going to be able to solve problems on the two forms of integration. Alright, let's dive into the discussion fully. What is integration? Like I said earlier, integration is opposite of differentiation, or you say integration is anti-differentiation. And we have this symbol to represent integration, long S. This symbol is called long S. It is used to symbolize integration. And generally, if you have a function x raised to power n to be integrated with respect to x, the simple process is to increase the power of x and then divide by the new power. That is what we have here. If I increase the power of x by 1, that will be x raised to power n plus 1. Then divide the term by the new power n plus 1 plus c. And that is the integral process of this function. Let me take it again. To integrate a function x raised to power n, the process is to increase the power of x by 1 and then divide by the new power, which is what we have here, x raised to power n plus 1 over x plus 1 plus c. Plus this c stands for arbitrary constant of integration, and we use it when the integral form is indefinite. So this is a type of integration called indefinite integration. And how do we know if an integration is indefinite? That is when the upper limit and lower limit are not given. Like for this function, this integration, this integral, the upper limit is not known and the lower limit is not known. So it makes this indefinite integration. And another difference between definite and indefinite is the use of constants in indefinite. But for definite, constant c is not used. We are going to see by the time we start to solve problems. Now, I have on this slide a display to show that integration is opposite of differentiation. Like I have this function x raised to power 3. If this function is differentiated, I will have 3x raised to power 2. And if this result, which is what I have here, is integrated, I will have x raised to power 3 plus c. And with this, we can say that differentiation is opposite of integration and so on. The next display here is to buttress the opposition between integration and differentiation. If this function 2x is integrated, I'm going to have any of these function. And if any of this function is differentiated, I'll have this function. All I'm saying here is to show to you that integration and differentiation are opposite to each other. Now let's look at some problems. Now we have this problem to be solved. You have to integrate a function x raised to power 2 minus 4x cubed plus 2x power 4 with respect to x. So what I'm going to do in this case is to integrate each of the terms individually. So if I'm to integrate x raised to power 2, the process is to increase the power of x by 1 and divide by new power, which is x raised to power 2 plus 1 over 2 plus 1 minus 4x raised to power 3 plus 1 over 3 plus 1 plus 2x raised to the power 4 plus 1 over 4 plus 1 plus c. You can see that I have increased the power of x in this function and then divide by a new power. For x squared, I will increase by 1 divided by a new power. For 4x cubed, I will increase by 1 then divide by a new power. And for 2x raised to the power 4, I have increased by 1 by adding 1 to it and divide by a new power. And going further, that will be 3, 2 plus 1, that will be 3. I will have x power 3 over 3 minus 3 plus 1, that will give me 4. That is 4x power 4 over 4 plus 4 plus 1, that will give me 5. That is 2x power 5 over 5 plus c. And in this, I can have 4 cancelling 4 here. I'm going to be having x power 3 over 3 minus power 4 plus 2x power 5 over 5 plus c. And that is the end of that solution. Now, moving forward, another problem is this. We are asked to integrate x power 5 minus 3x power 3 over x squared with respect to x. Now, in this type of problem, it is important to split the function into individual fractions before you can integrate. What do I mean by that? We have this. If I split this into fractions, I will have x power 5 over x squared minus 3x power 3 over x squared. This is what I'm going to have here. Then I'm going to divide x power 5 by x power 2, and that will be x power 3. Simply deduct 2 from 5. That will be 3. Then minus divide 3x cubed over x by x squared. That will be 3x power 1. Or simply say 3 minus 2. You have 1 here, the x. So this fraction, this function, rather, is easy to integrate, and that is going to be, don't forget the process. The process is to increase the power of x by 1 and divide by the new power. That will be x raised to the power 3 plus 1 over x plus 3 minus 3x power 1 plus 1 over x plus 1. Right? This is going to give me 3x power 4 over 4 minus 3x power 2 over 2 plus c. And that is the end of the problem. Don't forget, c comes along with indefinite integral, and the two integrals we have solved are indefinite integrals. Okay, now another example is coming. We have to evaluate integral of 2 plus x all squared dx. To solve this, we have to first of all open the bracket. We simplify the content of the integration, and that is going to be, if the bracket is open, I'll have that to be 4 plus 4x plus x squared. By the time you open this bracket, then it's easy for me to integrate each term here, and that will be 4. If I integrate 4, that will give me 4x. Now, before I go further here, anytime a constant is integrated, you just multiply that constant by the variable with which respect you are integrating. For example, you have 4, the integral will be 4x. If you have 5, integral will be 5x. If you have 1, integral will be x. If you have 7, integral will be 7x. So if you are integrating a constant, you multiply that constant by the variable with which respect you are integrating. So I have 4, integral to be 4x. If I integrate 4x, I will increase the power of this x by 1 and divide by the new power. That will be 4x power 1 plus 1 over 1 plus 1 plus x raised to the power 2 plus 1 over 2 plus 1. And that is going to give me 4x plus 4x squared, that is 1 plus 1 over 1 plus 1, which is 2, plus x cubed over 3 plus c. Then 2 can go in 4. I'm now going to end my solution with 4x plus 2 in 4, 2. That will be 2x squared plus x cubed over 3 plus c. And that is the end of that solution. All right. We in the last 6 to 7 slides I've explained, I've been able to define integration, And I've been able to discuss the types of integration or the forms of integration that we have. We have the definite and indefinite. So far we have been talking about indefinite integration. And don't forget that under indefinite, we don't have upper and lower limits. And the end solution of indefinite comes with constant c. All right. We are going to talk more about the constant. We can find the constant, but that will be discussed later. If further details about the question, if more details are given about the question, you can find C. But that will be later. Now let's go into discussion of definite integral. For definite integral, you can say this is a definite integral because we have limits. We have the upper limit and lower limit. The B here is the upper limit, A is the lower limit. And one other thing we need to quickly understand here is that the upper limit is always greater than the lower limit. The upper limit is always greater than the lower limit. They are never the same. Upper limit and lower limit are not equal. The upper limit must be greater than the lower limit. So take hold of that. Now we have, let's assume that this function, the integral of f of x with respect to x is capital F of x. Let's assume that the integral of small f of x with respect to x is capital F of x. Let's assume that this is the integral form of this one. All right, there should be plus c here if this is to be indefinite, right? Now, if we make it definite, it means that these are our results. We'll have upper limit and lower limit. That is upper limit b, lower limit a. Let me take it again. If f of x, the x is f of x, that is the integral form of this function is this. Then the upper limit will be placed up here. The lower limit will be placed down here. Solving it further means that I will substitute upper limit into this. That will be fb minus, and then substituting lower limit, which is fa. So the final result is the substitution of upper limit minus substitution of lower limit. Let's see how this can be applied in solving problems. All right, we have integral of x squared with respect to x, upper limit 2, lower limit 0. Now, if you want to solve this, if this is integrated, it will be x raised to power 2 plus 1 over 2 plus 1. And that will be x raised to power 3 over 3, which is what I have here. X raised to power 3 over 3. Then upper limit 2, lower limit 0. Don't forget, you have to put this. And C is not used when we are talking of definite integral. Okay, so by the time I substitute upper limit here, that will be 2 raised to power 3 over 3. That will be 2 raised to power 3 is 8 over 3 minus, and I put 0 here. That will be 0 raised to power 3 over 3. And 0 power 3 is 0 over 3. All of this is going to be 0. If I have 8 over 3 minus 0, the final answer is going to be 8 over 3. And that is the end of that solution. But something new we are bringing in here are the limits. I have limit and no use of constant c. You should put that into your mind. C is not used when we talk of definite integral, while C is used when you talk of indefinite integral. Okay, now let's look at another problem. This one is a past question, but the reference is not here. We are to integrate square root of x plus 3x with respect to x with upper limit 4 and lower limit 1. Okay, for you to simplify this, for you to integrate this, you have to simplify this root x. Root x, don't forget, can be x raised to power half plus 3x with respect to x. Now, if to integrate the content here, it will be x raised to power half plus half over half, x raised to power half plus 1 over 1 plus half, plus 3 raised to power 3x raised to power 1 plus 1 over 1 plus 1. Don't forget the process. Increase the power by 1 and then divide by the new power. If I increase power of this x by 1, that will be x half plus 1 over half plus 1. Plus, if I increase power of this, the power here is 1. So I increase by 1 again, it will be 1 plus 1 over 1 plus 1. So solving it further, 1 plus half will give me 3 over 2 over 3 over 2 plus 3x. 1 plus 1, that will give me 2. That will be 3x squared over 2. Now I'm done with the simplification. So I need to substitute the upper limit and lower limit. And if that is done, if I'm to substitute the upper limit, which is 4, I'll put 4 here. That will be 4 raised to power 3 over 2 over 3 over 2 plus 3 brackets 4 raised to power 2 over 2. I'm going to put 4 into this first. I'm having this minus, I'll now use 1. That will be 1 raised to power 3 over 2 over 3 over 2 plus, if I put 1 here, that will be 3 times 1 square over 2. Solving further, 4 raised to power 3 over 2 will give me 8. Okay, over 3 over 2 plus 4 times 4, 16 times 3 divided by 2, that will give me 24. Minus 1 raised to power 3 over 2 should give me 1 over 3 over 2. By the time I find the inverse of this, it's going to be 2 over 3. Plus 1 square is 1. 1 times 3, 3, 3 over 2. I'm having this. Okay. Now taking it further, by the time you simplify 8 over 3 over 2, that will be 16 over 3 plus 24 minus 3, 2 over 3 plus 3 over 2. Then simplifying further, if the first bracket is simplified, that will give me 88 over 3 minus, simplifying the second bracket, I will have 13 over 6. Then 88 over 3 minus 13 over 6. I'm going to look for the LCM here, which is 6. So when you simplify further, you are going to have that to be 163 over 6. You can leave your answer like that. And that is the end of that solution. And what I need to quickly bring to your understanding again is that the final result of definite integral is known. The final result of definite integral is known, which is 163 over 8 over 6, excuse me. But in indefinite, the final result is not known because it comes with the constant c. And when the c is not known, it means the function is indefinite. Right. Another problem for us to solve. Okay, you can see that in each of the problems we are solving, one thing there is a feature that makes it different from the other one. Like this one we are going to solve now is different from the first one, from the last one we solved. The last one we solved is different from the first one we solved under definite integral. So you have to understand the peculiarities of these questions. Now this one is saying that the integral of 2x minus 1 with respect to x equals to 4, upper limit k, lower limit 2. You can see in this case, the upper limit is not known, it's unknown value, and the lower limit is known to be 2. So we are asked to find the upper limit. So this answer is wrong. It should be wrong. Let's find out it's wrong because I said earlier that your k should not be equals to 2 because the upper limit must be greater than lower limit. And upper limit and lower limit are never the same. They can't be the same. They must differ. But the upper limit should be more than the lower limit. So it means that this answer I've put here is wrong. Maybe it's a typical error. But let's go on with the solution and find out which answer is correct. Now, to do this, we are going to simplify individually as usual. So if you integrate 2x power 1, it will be 2x raised to power 1 plus 1 over 1 plus 1. That will be 2x raised to power 2 over 2. Minus, if you integrate a constant 1, it will give you x. Then you have upper limit k, lower limit 2 equals 4. Now the next step is to substitute this k minus substitution of lower limit. So if that is done, we have this one is talking about 2 cancelling 2. I have x squared minus x, upper limit k, lower limit 2. Then substituting the upper limit, I will have k squared minus k, minus substituting the lower limit, I will have 2 squared minus 2 equals to 4. Right? K squared minus k minus 2 square will give me 4. 4 minus 2, that is going to be 2. I will have minus 2. That is this minus 2 you have here. That will be k square minus k minus 2 equals 4. Simplifying further, by the time you bring this 4 onto this side, you have k square minus k minus 2 minus 4 equals 0. Minus 2 minus 4, that should be minus 6. I will have k square minus k minus 6 equals 0. Then, if this one is solved quadratically, I will have k square minus 3k plus 2k minus 6 equals 0. And I'm going to be having, if I factorize what is common to both sides, I will have k plus 2 multiplied by k minus 3. With this, I can have my k to be equals to minus 2 or k equals 3. Now, if I ask the class which of these two answers is correct, the correct answer is k equals 3, because I said earlier that k upper limit must be greater than lower limit. I have two values, minus 2 and 3. Minus 2 is less than 2, so we cannot go for minus 2. We can only go for 3, which is more than 2. And that's why I said this answer is wrong. So the correct value of k is 2, since the lower limit is, the correct value of k is 3, since the lower limit is 2. Right? You have to pause this video and answer these questions based on what we have discussed. In the lesson, we have been able to define integration. I've been able to relate it to differentiation. I've listed the two forms of integration, which are the definite and indefinite forms, and I've been able to solve problems under each forms that we have. So I want you to take this question, pause the video, solve this question based on what we have discussed so far, and I'm sure you are going to be able to do this. You can see the first question is coming from WAEC, the second one is coming from NECO, third is coming from NECO 2015, WAEC GC 2015, the last one is coming from WAEC 2015 question 9. I believe I've been able to make sense of the content of this class. Thanks so much for your audience. If you haven't subscribed to the YouTube channel, I advise you to click on the subscription button so that when videos are uploaded, you can get the videos directly. Assalamu alaikum warahmatullahi wabarakatuh.